for coming and for being ready for our special guest today. I wanted to make a few quick announcements. First, I wanted to just thank and welcome the group from Altoona. Can you guys stand up? Actually, they made a trip, and let's give them a welcome. Hello. Okay, you can be seated. They're from a brand new Christian school called Arrows Christian School, and a lot of these students were homeschooled before, and they made a special trip up for the talk and the lab. And Mr. Harper over here is married to Miss Jess, who's part of our hybrid. So we have this neat thing. So we also wanted to just thank the Access Church. Pastor Zach and Ashley McDonald said yes, so thank you. And if you are not familiar with the facility, there are restrooms on this floor between here and the fellowship hall. And if those are filled and you really gotta go, you can slip downstairs. There's two more. You came in the front stairwell, but the stairwell right by the kitchen, there's bathrooms at the bottom of that. If you need to go, I just ask that you just very quietly slip out of the room, use the bathroom, and come back so that we don't disturb other people or Mr. Armitage while he's speaking, okay? I love it. I see lots of people with their notebooks out, ready to take notes. We're going to get to see a lot of specimens today, but I wanted to explain to you how Dr. Armitage, what do you prefer? Okay, Dr. Mark. I grew up south of the Mason-Dixon, so we don't just say Mark. Mr. Mark, Dr. Mark. How he got here, because he'll share with you some. He's from Seattle. He and his wife flew to the East Coast and are here visiting. But the way that they got here is through someone that has been working with them. This is Mrs. Allen Mchenry. Can you say hello? Many of you know Mrs. Mchenry. I am going to introduce, some of you do not. Mrs. Mchenry is a state college resident, and she has been homeschooling and working with homeschoolers for about 30 years, maybe a little more, 25, 30 years. And her expertise, her background is in science and art. So she is an artistic scientist who actually writes and publishes material that is sold all over the world. And for the hybrid kids, we're doing some memory work called Claritas. On the Claritas website, whoever created the Claritas website actually linked several things back to Mrs. Mchenry's work. So that's how well she's known and has been publishing material. She has some classes going on from time to time when she needs to try out new things, and we might see her again. So Mrs. Mchenry has material over many different subjects, but forged a relationship because she's a creationist, believes that God created. This is of great interest to her because what we're going to talk about today is a scientific area that usually people use to say that the earth evolved, that evolution is true. And Dr. Armitage has studied this with direct evidence for creation. So Mrs. Mchenry is going to introduce him, but I would like to just say a word of prayer together, that our minds and hearts would be open for what the Lord might have us learn today. So let's bow our heads together. Lord, we thank you for everyone that's in this room today, that you had planned for us to be here, that you made a way for Dr. Mark to come, that you, years ago, inspired Mrs. Mchenry to connect, and that you gave them a rapport and a friendship that your truth could be shared in many places. I pray, Jesus, you would open our minds for understanding, that we wouldn't be intimidated by big words or new words, but instead we would just hear them and take in new understanding today. I pray that you would touch our hearts in understanding your plan, your creation. And I pray that as we learn and understand new things, that it would help us to be able to love well and to be kind and understanding towards non-believers who think differently. Lord, we ask your blessing on the Access Church and all of those who made today possible. We ask your blessing on Mrs. Mchenry and her work that she's doing. And we ask your blessing on on Dr. Mark and his wife and their ministry in sharing the truth of your creation and your goodness. We invite you into every part of this day, and we ask this in Jesus' name. Amen.
Okay. Well, this is going to be real short because I think you did a great job of introducing all of us. So, as part of the work I do in writing and teaching, I'm a real sucker for new things. There's a new idea. I'm like, ooh, I got to find out about that. I love new ideas constantly. Some of them end up in books, some of them don't. And then a lot of my new ideas, I have what I call my guinea pig groups. Some of you have been in my guinea pig groups, and I try out these ideas. But at any rate, part of my research involves a lot of reading and watching. And through YouTube, I watch a lot of science videos. So one day, this is about, 6 or 7 years ago, YouTube popped up a suggested video, and it happened to be one of Dr. Mark's earlier videos on dinosaur soft tissue, the work he was doing. And I was just riveted. Full attention. And at the end, he said, something like, this isn't rocket science. You guys can do this. Like, you can do this. I can teach you how to do this. And I went, okay, I'm going to take you up on it. And so I knew somebody out west. How do you get connected with somebody you see on YouTube? But I knew somebody that knows a lot of all the big name creation scientists. So I emailed him and I said, can you please put me in touch? And then I just wrote a letter and introduced myself, something like that. And we've been kind of email corresponding. We've been working on the plan of trying to get him to Pennsylvania, and so here he is. And so I don't know what you want to tell about your background, parasitology or whatever you want to do. I'm just going to let Dr. Mark introduce himself and his work, and that's it.
She's awesome, isn't she? You guys have a real treasure in this lady. I want you to know that, okay? She's a special educator, very special. She learns like I do, kinesthetic learners. You got to touch it. You got to taste it. You got to rub it on your head to see what it is. So I have a monumental task today. I have to give a whole bunch of adult information in a way that you guys can understand it. Wow, my work is cut out for me. But I'm really, really glad to be here. This is kind of an experiment, really. We're kind of flying by the seat of our pants here, yeah? We're going to try to put on some workshops and let you guys see with your own two eyes these cells. And I have a cell right here. I don't know if you can see it on this monitor, but it's on this microscope, actually. It's on a slide, and I can prove it by focusing in and out. So last night, when we got here to try to start setup, Mrs. McHenry had already been running an acid experiment. We put these bones in a weak acid. I'll describe that process to you. And for how many days had you had them?
It was less than a week. It was
Okay.
not long. I was afraid it was not long enough.
So these were fresh bones that we collected in Montana not longer than about a month ago. That was a hard trip. We drove 2,600 miles and dug for 3 days in Hell Creek. There's a reason they call it Hell Creek. It's not a hospitable place. But we found these fabulous raptor bones, and we shipped them off, and Ms. McHenry put them in this acid. And last night I said, let's just try. So we took a pipette and took some of the solution out, put it on a slide, put it under a microscope, and found not only a cell within less than a minute, and you found another one later, we found nerves. So we have some fun things to talk about today. So I'm going to try to do this PowerPoint for you in a way that hopefully everybody's going to understand, and hopefully I'll push the right button also. That's right, you have control. I have no control up here. So next slide, please. That's right. Class, pay attention to the professor forgetting his lesson already. I have a clicker. Look at that, and it works. Thank you, Jesus. Okay, just a couple of things about us. We're called the Dinosaur Soft Tissue Research Institute. That's a mouthful, but those are important words. We're an institute. What does that mean? We're a scientific organization. Do we minister to people? Yeah, we do. This is really important. We want everybody to hear this. That's why we were able to speak on the campus of PSU this morning. Yeah, and they live streamed it, and we got questions from folks. So this is really getting people's attention. And so as an institute, we want to be purely scientific. And that means that we publish in real journals. And we have books for you today. We have free books. Everybody gets 2 copies, one copy of each of them. And you'll see the actual published work. So we are scientists. We actually go to the dig, we find the bones, we bring them back to the lab, we put them in this weak acid, and we dissolve them. And that allows us, that allows us to get all the soft tissue out. And I'll explain that whole process. Now, you already have a question. Good.
Well, if the acid is weak, then how does it dissolve the bone?
Great question. It's strong enough to dissolve the bone, but weak enough to preserve the soft tissues. However, if you do let the preparation sit in your dish for too long, it will erode the soft tissue. So it is still an acid. It's just a weak one. Another question.
Is that like how vinegar dissolves?
Yes. It actually decomposes the hydroxyapatite. Yeah, okay, big word. The bone mineral gets deconstructed. And so that bone will sit in that acid and things will just kind of fall apart. And then we go in with a pipette. You know what a pipette is, right? It has a little rubber bulb on it so you can draw up a liquid with it. So we just squeeze all the air out of it, put it on the dish, drag it across the dish as we let the air or the water go into it, and then we put that on a slide. And so if you're going to be in the workshop, how many are going to be in the workshop later today? Yeah, a bunch of you. So you're going to hopefully get to see some of this yourself. Okay, so we are an institute, we are a dinosaur soft tissue institute, and we're a research institute. We try to do teaching as much as possible, but we're doing the work that needs to be done. We'd worked with some other organizations in the past, and that didn't seem to work, so we thought, you know what, we're just going to go for it, and the Lord has blessed the effort, and you're going to see some of that today. We have a website that you can go to, Mom and Dad, if you want to supervise, distri.org, dstri.org. Some of our videos are up there. All of our papers, our books, the books that you're getting today, you can download those for free and print them off and give them to somebody or put them on a thumb drive. We want all of our materials to go out free of charge. That's the way the Lord did his ministry, isn't it? Didn't he give himself away? Give everything away, didn't he? That's what we want to do. And that's what we're trying. And so far, it seems to be working. So all of these things are up on the website. You can download some of these, but we want you to take your copies today. Now, here's an advertisement for us. We're called a 501c3 organization. That means at the end of the year, if you need a tax write-off, you can give us money. And I used to ask for $50 million. I dropped to 25. And I hung on to 25 for a long time. But that didn't seem to work. And then I gave a fire sale at $5 million. If you give us $5 million, it's a fire sale, bargain basement price, and we can get some work going. Now I'm down to $100,000. So if you've got a checkbook with you today, you'll get a tax write-off on that money that you give us. Seriously, we need this money. Why? This is expensive to do this work. That's why a lot of people don't do it. It's expensive and it takes a lot of training. Now, I need workers. I need helpers. I'm getting old. In case you haven't noticed, see all this white hair up here? So, my bones are creaking a lot. Are you trying to tape me back there? Should I be standing in one place? Okay, I'm sorry. I get going and I forget. I need workers. How many of you guys would be interested in thinking about, already one hand, a career in soft dinosaur soft tissue? Okay, that's good. You guys come to my workshop, okay? And, well, we'll get you in. We'll figure it out. Okay? Tell Mom. Mom. What? I want to go to the workshop. Try that. Am I bad, parents? Am I being bad? I hope not. I need workers. I need helpers because I can't do this all by myself. And so what we're hoping to do is set up a laboratory station, a permanent laboratory station, maybe right here in this area, since you guys are already ready for this stuff, and putting one maybe in Montana. That way families maybe can travel to the lab on vacation. Yeah, Dad. Yeah, Mom. And go to a workshop at a real laboratory. This is what we're praying about. Would you pray about that too, please? Because we think we want to take this to the homeschool community and train you guys. If you learn nothing else today, if this is the only thing you learn today, know that you can trust the Word of God 100%. You don't have to doubt anything in it, even if you don't understand it. Okay? And what you're going to see today is proof positive. The flood was real. The flood happened. It happened all around the earth, and we're chasing this layer. It's called the Jurassic. You want to write that one down? Jurasic. Did I do that right? The Jurassic layer is what contains Triceratops and T-Rex and Pachylophosaurus and Brachylophosaurus canadensis. And all these critters, they're in this one layer all around the earth. We're going to chase that layer around the earth. This is why I need workers to go with me. Help me dig. Help me bring these bones back. Learn how to work with them in the laboratory. Learn to write scientific academic papers that you can publish. Yeah, you can do it. If I can do it, you can do it. And that's what I need for this organization. Okay, I want to begin with a tiny bit of review. The title of this talk is Tissues of the Permian. Okay, let's go back to that slide, because that's a pretty slide. You like that slide? Who can tell me what that guy is? Who is that? Dimetrodon, Permian, yes, Permian. Well, the word I gave you on the screen. I mean, come on. That's Dimetrodon. Who's heard of Dimetrodon? Yeah, he was an ancient lizard. This is supposed to be 290 million years old. Yes.
Is there prehistoric, bugs?
Yeah. His question was, are there prehistoric bugs? There are not only prehistoric insects and things, but there are parasites in those insects. Yeah. I got my master's degree in parasitology. It was really gross. I got to cut up a lot of intestines to look for parasites. I can train you if you want. We went to Oklahoma. We were reading in the literature. We do a lot of reading in the literature to find out where these layers are. Write down the word Permian, and next to it, write the number 290, and then put MY, million years ago. This guy's supposed to be almost 300 million years ago. Now, you don't understand what that number is. I don't understand what that number is, right? But think of it in terms of 1,000 years. Who would like to live 1,000 years? On this planet, take your hand down. Nah, you're going to live in the better place for more than 1,000 years. But think of your life in terms of 1,000 years. If you lived 300,000 times that number, this is the number we're talking about. It's deep, deep, deep time, according to the evolutionists. Now, I'm not going to beat up on evolutionists today. Jesus said, be merciful, didn't he? If you're arguing with people over this, stop it. Stop it. Don't argue. Why? We have the facts now. We don't have to argue anymore. All we have to do is give our testimony, preach it in love, right? That's what we're trying to do. So we're finding tissues in these guys that looks better than the tissues we have found in these guys. Why is that? I don't know. These are much younger. Hand up if you know how old these are. Anybody? See how old? These guys? No, these are more like 68 million. Is that what you're going to say? Yeah? 68 million. These are 68 million. Now you're talking, okay, I'm talking scientifically. You're talking what we know to be true. So you are correct in what you said. Maybe 4,000. I tell people, say, how old is the earth? I'll give you 1,000,000 years. You can take 1,000,000 years if you want. I don't care. The tissue's not going to last that long. Okay, when I began my career, the reason I got into this is because I was trained in soft tissue processing. That was my career. So when I read these papers and saw what are they doing in these papers, they're processing soft tissue. I can do that, and that's why I jumped into this. But we know they don't last that long, right? You can try a little experiment. Hand up if you have a kitten as a pet. Anybody have a kitten? A couple of you do. What's your kitten's name, dear? Stella and Bear. You have 2 kittens. Stella and Bear? Okay. Well, let's pick Stella. You love Stella? Is she cute? Yeah. I want you to come home and hold Stella in your arms real tight because she's going to squirm. And I want you to twist her neck until she stops wiggling. What did you just do? You just created a potential fossil. Didn't you? You just created a potential fossil. Why? Because you're going to dig a hole in the backyard and put Stella. You're going to put Stella in that hole, covered over, put a little sign there. Mom and Dad especially, do not disturb. This is a scientific experiment in progress. Or better yet, just put Stella on the ground with a fence around her. And let her just leave her here. No, I love animals. You got this is how I make you remember the stuff you're learning today, okay? How long is Stella going to hang around on the ground? How long? Shout it out. A year? Is Stella going to lay there for a year patiently? No.
Until she's stuck up.
Well, yeah, but what if you lay her on the ground? What if you lay her on the ground? I found these bones, I found on the ground, on the surface of the ground. I'll show you pictures. Now, we know, okay, you have a question because your hand's up.
I was going to say like a couple months.
Probably a couple months, right? Try it with a peanut butter and jelly sandwich. Mom and Dad, I know you made me this delicious sandwich, but I'm going to do an experiment with it. We know that soft tissues don't last a long time. We know that inside, right? Nobody had to tell you that. You know what happens when a fish dies in your aquarium. The first thing that happens is the other fish eat his eyes, right? But then he rots. He floats to the surface. Why? All the bacteria that were being held in check with his immune system are now free to eat anything inside the fish they want to, and they're making gas. And the gas is bloating up the fish. This is why you see dead animals by the side of the road all bloated up, right? If they're not smashed, they're bloated up. Why? It's the gas. Soft tissues go away. Soft tissues don't last. How can the earth be old if soft tissues are still present on it? Yes, sir.
You said that the soft tissues don't last for long. How long do you think they'll last?
That's a great question. How long do the tissues last? As a microscopist, which is here's another word, microscopist, M-I-C-R-O-S-C-O-P-O-S-I, did I get it wrong? P-O, I can't spell. Microscopist, yes it is, thank you. As a microscopist, I was trained to process tissues on ice. You understand what I'm saying? My tissues had to be 4 degrees centigrade cold. Why? Because they degrade so fast. That was my training. Now we're digging stuff out of the ground that hasn't been at 4C for a long time. How is it still there? Do you know? No. I don't know. Do you know? How? I don't know. I don't know. Do you know?
Perfect conditions, a lot of winter and a lot of sun.
But this stuff has been in the ground for who knows how long, and it's gone through freeze-thaw cycles every year for how many years? Freeze-thaw, 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 water flowing through it. You know water just naturally breaks down tissue? If you just put a slice of ham under another experiment for you, Mom. Sorry, house is going to be stinky for a while. But just try it. Take a piece of ham, put it under running water for about 6 months, and watch what happens. It'll totally degrade just because of the water. Okay? So, we don't know how these are preserved. That's the whole point. We think that they're young. So let's come back to this slide. Before we talk about tissues of the Permian, let's talk about Triceratops a little bit more. This is 68 million year old material. Where's my laser? There it is. See that? 68 million years. They call it Cretaceous. This is what they use. I use their terminology so that They're going to understand me. I don't need to win you guys to Jesus. You're already won to Jesus. Who do I need to win to Jesus? Yeah, right? So I use their terminology. Paul says, I became all things to all men, so that by all possible means I may win some. That's what we're trying to do. So we use their terms, Cretaceous. All right? This is a slice of bone. So these bones that you saw here, we thin section them. We use a special machine to cut them so thin they're half the width of one of your hairs. Yeah? That's pretty thin. Now I want you to notice something here. You see the bone, it's kind of reddish brown, right? This is the white coming from the microscope. What is all this black stuff? What is all that? Sand? That's a good guess. Why? These have been in the sand for a long time, right? And we do pull them out of sand. Yes, sir. Real loud. That's another good guess. Why? Because they're in the ground and we expect there to be bacteria. In fact, I'm going to show you guys something that I haven't really been showing a lot of people. I've done a lot of these thin sections. See that right there? That's a nematode. See that right there? See that right there, right there, right there? Suddenly you see all these nematodes in there, don't you? I don't talk about this a lot. Why? I need to study this more before I publish it, and I'm going to publish it. If these things are full of worms, why are they full of worms, class? Why do worms go in bones? Because there's soft tissue in there that they want to eat. Yeah? Yeah, pretty cool. All right, this black stuff, we wondered too, what is that? I want you to notice one thing. See all these holes in here? All those holes are blood canals. The bone has canals in it. Write that down. Bone, B-O-N-E, canals, C-A-N-A-L-S. Hang on one second. The bone, your bone, my bone, is full of canals. Why? The blood vessels ride through our bones. Why? They have to feed the soft tissues that are in there, the cells that are in there. We're going to talk about those cells. Do I need to hurry up, or do I have an immense amount of time today? Well, what time is it now? Okay. So we wondered what this was, and we decided we're going to study this because we think this is clotted blood. It's dark. What color is blood? It's dark red. It's in the canals. Where's the blood found? In the canals. What if they drowned in water and suffered a condition which the doctors talk about called disseminated intravascular coagulation? Say that 3 times in a row. What does it mean? It means when you die in water, water drowning victims, their blood clots throughout their whole body, including their bones. It's a condition. If you're resuscitated after a drowning event, let's say you fall in a pool and you die, somebody brings you back to life, the blood clotting cascade goes the opposite direction, and you do what? You bleed out. You talk to any ER physician, any emergency room physician will tell you that if you die in water by asphyxiation, all your blood is going to clot. So we thought, well, what if they drown in water? And so we used a special microscope to look at these canals. And here's what I want you to see. This is a regular microscope like this one I have on the table. So just light coming through, and you see the bone canal, but look at all this black stuff in the canal. And look at how it hasn't left the canal. It's all still where? In the canal. Right? Here's another one. There are little holes in the center too. This is almost completely occluded. But we put it under a special microscope that does what's called fluorescence in the UV. You can't see UV with your eyes. This is why you don't look at the sun, because there's a lot of UV light coming from the sun. We use it in a special microscope, and look what it did to the iron. It made it glow. The iron started glowing. We thought, wow, that's interesting. And we looked at 6 different dinosaurs. We thin-sectioned all their bones. They all have clots in them. And then we looked at the papers that are in the literature that the scientists are writing. I look at their pictures and I see the clots in them. They don't see the clots. But because we've done this work, and this is published now, this is all published. So we've had 6 individuals with clots in them from this time period, supposed 68 million years ago. Do you understand the significance of this? If there are clots in every dinosaur bone that we recover, what does that mean, class? They drown in water. Say it again. They drown in water, right? And you'll read this in our book, in the green book. You'll see the clots. So we're giving you evidence that you can share with your friends. You don't have to argue. Why? You're just presenting the facts, right? It's not about arguing. So this is important. I'm not going to spend the time to talk about this. A lot of this is adult material, but in terms of the understanding, because they say that the iron preserved the tissues. How many have heard that? The iron preserved the tissues. Okay. Well, if the iron is still restricted inside the clots, inside the canals, how did it go out into the bone and preserve all the material? Yeah, no, it didn't. See, it's in the canals. The clots are in the canals. Have I been saying that wrong? I start talking and my brain goes to lunch. So, anybody want to have lunch? It's time, isn't it? Okay. Anybody not understand this about the clots? I'll explain it again if it's not real clear to you. They drown in water. When you drown, your blood clots. We're finding clots in all of them. Means they drown, okay? So we think that's pretty important stuff. Now, I mentioned already that we saw nerves in our preparation last night. We're finding nerves, and we published this. We submitted it to a journal. What we did is we compared chicken bone nerves with the nerves we're finding in these. Why did we use chicken? Because they say dinosaurs were the ancestors to chickens, right? When you have turkey dinner this Thanksgiving, you're eating dinosaur. That's what they say. Anyway, so we want to speak their language, right? So we use their model. We use avian model. And what did we find? This is a condyle. Let's see, do I have these pictures here? No. This is a condyle. It's a round bone about the size of a softball. It comes out of a triceratops. You see that big head? That big head is the biggest terrestrial head known to man. Yeah, it's on the back wall. See it back there? That big head? That's the heaviest terrestrial, not aquatic, because whales, their heads are a little bigger. This is the largest terrestrial cranium head known to man. All that weight rests on that little round ball at the end of the vertebral column. So you have the vertebral column, it's horizontal, like a cow. You have this ball in the end, it's a universal joint, and you got this big head, right, hanging off that. So is this an important bone? Yeah. Did they take notice when we talked about this? Yeah. We found nerves inside of this bone, and we compared them with chicken nerves, and they look identical. And what did they do? What did the journal do? They put our pictures on the cover of their magazine. Isn't that phenomenal? I was blown away. I was like, thank you. Why? They're recognizing the importance of the work. Why? Because all we're doing is presenting the work. We're not arguing. We're saying, this is the science. Do you see how that works? All right, let's talk about bone for a minute. I'm going to go quick because this is a lot of detail that, is probably not important to you at this level, but I want to point out a couple of things. Imagine a long bone. Imagine your long bone. You've got a femur, right? Imagine your femur. You take that bone out of your leg. That's going to hurt. But let's say you saw that thing in half and you look at it. This is what it looks like. Okay, that's a cross section. This thing's not very bright. This is a cross section here. It's like a pie. You see the pie shape? And there's all these lines in here. What's that? All these lines are bone lines. They grow in circles. Bone grows in circles. Yes?
Are they like how trees grow? Like how old they are?
That's a great question. They're not like tree rings, although they can tell if bones are old, but based on another thing. Not the rings. That's used in what? Trees, right? Yeah, that's a good question. What happens is there are cells in here. Let's talk about these little cells, like the one I have on the screen here. This little cell, this is called an osteocyte, a bone cell. And he's got all kinds of wiggly fingers that go out. Wiggly fingers. They're called thread feet. Filopodia. Why do they go out? Because they all touch each other. They're all in the bone. See them all stacked in the bone here? These are right here. See this? See all those little bone cells in there? They're all inside the bone. They actually make the bone around themselves. Yeah. First they make a carpet, a collagen carpet. Collagen is the stretchy stuff you have in your face. They make this carpet and they lay down on the carpet and then they bring in all the bone mineral and they cover themselves up. But they have these little fingers that go out and they go up, they go down. And what do? They touch all the other cells. Why? They're measuring your compression while you're walking or running or picking something up. They are measuring the compression in your bones. Yeah, these little cells are measuring and they're fixing the cracks. Your bone cracks all the time. You may not hear it. You might feel it. I hope not. But your bone is always cracking. Why? It's a mineral. It's a soft mineral, but you're running. You essentially have a glass skeleton, basically. Now, these cells, some of them dissolve bone, and some of them make bone, right? What happens if you have too many cells that dissolve bone? What would happen to you? Yes. Yeah, there are people with that condition. It's brittle bone disease. And the slightest bump will break a bone. There are people who have that. So the cell populations in your bones are important. These cells are very important. And we're finding a lot of these, as you can see there. The other thing we're finding are in these canals. Here's the bone canal. Remember we talked about the bone canal? That's a bone canal. Here's another bone canal. That's a cross canal called a Volksmann canal. But these are the canals in the hard bone. So this is hard bone, but look at the center. Remember, this has been cut away. This is a pie slice of that cross section. You with me? Yeah? Got a question?
It looks like there's a red one, which is your artery, and a blue, which is your vein, but what's the white thing?
What's the white one? It's actually yellow. It's kind of yellowish. See it right there? That's a great question. What is it? Yeah, it's a nerve. They travel together. In your bones, you have vessels, veins, and nerves traveling together. So we thought, we're finding veins, we're finding vessels. I wonder if there's nerves. Yeah, we found them. Nobody else had found them before. Now, we had to go back, years back, into the scientific literature to find a drawing that described what nerves look like. And they have this crosshatch pattern. Do you see that? See the crosshatch? Going this way and going this way. And then it splits here. And this is a covering. This crosshatch pattern, that's a covering over the axons, which are here. See those little axons? Now, Miss Mchenry's made a wonderful couple of models of this that you'll get to see if you come in to the lab. But remember the old TVs where you had to plug a cable into the back of the TV? That black covered cable? That's called a coaxial cable. In fact, I think Ms. McHenry's going to go get some of those. They have the same exact crosshatch pattern in the metal. If you carefully, with mom and dad, use a razor to open that rubber coating and peel that off, you'll see this pattern in the metal that they use in the cable. This is an insulation. Why? Because these are electrical cables. What do nerves do? They transmit electricity. What if you didn't have a rubber coating around your cable on the TV? Could you get shocked from it maybe?
You get shocked, or it would go, the electricity would go somewhere where it shouldn't.
Yeah. You could disrupt the electrical signal. That's why it's covered in a coating. These are covered in fat. So we've got these examples up here, which, yeah, go ahead. Good. Pass those around. See the crosshatch pattern? When you're done, pass them back to the people behind you. So to go down the row and pass them back. So we found this picture then, and we thought, wow, if we look for this pattern, maybe we'll know we have nerves. And that's what we found. This is a chicken nerve right here. This was taken out of a chicken bone, right? Look at the crosshatch pattern in here. See it? Look at the dinosaur nerve. This was taken out of a Triceratops condyle. Looks identical, doesn't it? There's more. You'll see all this in the books we're giving you. So what are we finding? We're finding nerves. Fat-covered nerves. Fat-covered nerves. They're covered in what? Fat. Okay, fat. Have you ever had a jar of peanut butter with the oil in it? You got to turn upside down, right? Let the oil distribute. Then you have to whip that up, whip that oil into there. How many of you guys have had to stir the oil into the peanut butter? Yeah, you know what I'm talking about. So take that oil, pour it out on your driveway, put a little fence around it and a sign. Scientific experiment in progress. Mom and Dad, leave the oil alone. And let it sit there until your next birthday. Tell me how much oil you're going to find there. None. Yet these are covered in oil. Yeah? How can they be old? Right? Oh, the significance of this picture is this. When you look at these nerves that Miss Mchenry made, you see the outer crosshatch wrapping. See that? That's the insulation. That's the fat. Then you have these nerve bundles. They're called fascicles. And inside of them are the actual nerve axons. Right? We thin-sectioned one of these. Kind of like how we cut the bone. I told you we thin-sectioned these. We did the same thing with the nerves. We put them on a machine and we cut thin slices out of them. And what did we find? We found the layers of the fascicles inside the nerve. So you see that? I've cut it away. So this yellow guy that's sticking out right here, he's blue in this picture. See that? That's the fascicle. So we have proven that we have nerves because we found the internal structure. This is how the science is done. You publish this stuff, you go to meetings, you talk about it. Today at PSU, I got a lot of questions. Why? Scientists are a little skeptical. I had a guy write me from a forensic laboratory. Does anybody know what a forensic laboratory is? Raise your hand if you do. Yes.
Where they check out like fingerprints and that sort of thing, DNA.
Yeah, crime laboratory, right? That's a fun area of science. If you want to do microscopes, that's a great area of science. He called us, or he wrote me from the forensic lab, and he said, I regret to inform you that you are only finding cellulose fibers in these bones. Cellulose comes from plants, right? Plants make their own fibers. Animals make their fibers. So we did a test, and we compared them. I don't know if I have those pictures in here, but they're totally different. They're totally different. The crosshatch pattern, that shows you have a nerve. And I've got plenty of pictures of those. Yes, sir.
How can you tell if like between a rock and a bone? How can you tell?
Great question. How can you tell the difference between a rock and a bone? This is kind of fun. This is the licking part that I talked about earlier when you want to do science. Yeah, you put the bone on your tongue, dirt and all. You're going to do a lot of that when you're done, right? But you put the bone on your tongue and pull it. If your tongue goes, it means the pores, the bone canals, remember, in the bone, they're empty. You're putting moisture in them with your saliva, and it's going, give me that. Yeah, it's called capillary action. Write that one down. Capillary action. Yes, sir. Well, you pull it real hard, and it comes off. But rocks won't do that. A rock won't pick up your tongue. It also sounds a little different. We use screwdrivers to check these bones out, and you tap it. So you're going to have to come on digs, right? You're going to have to come on digs. Sorry, you're just going to have to come on a dig. But that's one test. Two tests you can do. You can tap it with a screwdriver, and sometimes the bones sound a little more hollow than the rock does. So, great question. Okay, who likes this guy? This is Nano Taranis. A lot of people thought he was a young T-Rex, but he's a whole different animal. This guy could run 60 miles an hour. Yeah. His teeth, if you look at a Nano Taranis tooth, it's serrated on both sides. It's a steak knife going this way, and it's a steak knife going that way. So this is a mean guy. And I used to do a talk called The Soft Side of a Mean Dinosaur. That was kind of fun. But we found a lot of stuff in him. Remember we told you we thin section these bones. Here's 2 thin sections that are about to be examined under the microscope. And what are we looking for in here? Blood clots, right? There we go. Here's a clot right here. I made it black and white so it's a little easier to tell. Is that easier to tell? That's the iron. Look at the iron glowing. The iron's saying, I'm here. I'm right here. But I'm not here. I'm not here. I'm not here. I'm not here. I'm not in the bone. Where am I, class? I'm in the canal. I stayed in the bone canal. This is Nano Taranis. Here's another one. Look at that beautiful bifurcation here. So that's a blood canal splitting in the bone. Look at how full it is of iron. That's iron. My microscope is making that iron glow. See? So that where did the iron stay, folks? In the canal. Didn't leak into the bone around it. Here's a rib. That's a vertebra. What was this one? That was rib. So yeah. So we have found clots now in 2 digs that are separated by 750 miles. So we're starting to build this database of information that we can then promote in the scientific community. See how this is done? It's very systematic. I'm just getting started. If I could afford you, I would hire all of you. But I can't. But come anyway, and we'll find money for you. I need workers. Okay, let's get to the Permian. Now we're talking about a time in Earth's history when all the continents are supposedly in one big smashed up unit. See that right there? Where's America? I don't know. It's like somewhere in here. I think it went that way, like 8,000 miles.
I see Saudi Arabia.
Do you? Yeah, that's probably this down here, right? Who knows? But was anybody there to draw this map? Did anybody draw this map when they saw it? Was somebody in a hovercraft or a drone unit floating over the earth and they saw this picture in the Permian and drew it? Nah, this is conjecture. This comes out of the mind of the person who thinks it was that way. How do we know it was that way? Well, we have clues. We know of tectonic plate movement. Yeah, we know that happened. But we don't know exactly how long ago this was and how fast it happened. They need the deep time because they need these things to move slowly. What if these plates traveled at 75, 100, 200 miles an hour? Can you tell me they didn't? No. Why? You weren't there either. But maybe they moved really quickly. We don't know. Anyway, that's this time in Earth history. So we're talking about organisms that were walking around here. These are some of their limbs. But they moved 8,000 miles that way. By the way, they have no scratch marks on them. I thought that was pretty funny. How do you move 8,000 miles without at least one scratch? I mean, he's not even in a U-Haul trailer. He's just in the dirt. Right? You with me, guys? That's the period we're talking about. Here's what it looks like today. So they moved over almost 300,000 times 1,000 years. Remember that 1,000-year lifespan I talked about? If you could live 1,000 years, would you do it 290,000 times? Yeah, that's a lot of time, isn't it? That's what they're talking about in terms of time. All right, we're talking about 2 different creatures. Eriops is one. Short, stubby. This is an amphibian. What are other examples of amphibians today? Yes, frogs, salamanders, all that stuff, right? All that stuff. Not quite lizards. They come a little later. But amphibians, they like the wet. But these guys were in and out, so they think they were in a little swampy area 290 million years ago. And so they have collected this is an actual skeleton of these guys, and we collected some of their bones. Also K-Cops. Now, this guy was about 6 feet long, so he would have made kind of an interesting pet. This guy was 6 inches long. That would have been a cool pet, yeah? K-Cops. But we studied these limbs, these little limb bones. See these here? These guys. We studied those, and we found nerves in them. We already talked about this, right? I don't need to go through this again, but just to point out, this yellow one, that's the nerve. See that? And that's what we're finding. So Eriops, 6 foot long, supposedly 295 million years old. A lot were found in the Texas red beds, but we went to Oklahoma in Lawton. You can go there. You can find this stuff yourself. We put them in a weak acid. What did we find? Liberated cells, liberated tendons. What's a tendon? Tendon is like a support ligament that runs along your bones, right? We're finding tendons, all right? Clots, fully clotted vessels, and clot canopies. What's a clot canopy? Think about a tree canopy. Does that give you a hint? You're going to see this. It's pretty cool. Here's the cells. Look at those beautiful cells. Those are 290 million-year-old bone cells. Yeah, right? I don't think they're that old. I think these died in the flood, right along with the Triceratops, same time frame. I think this is all one event. Beautiful cells, clusters of cells. Look at these clusters of cells, right? Look at the preservation. How did these sit around for 300 million years old just so that I could capture them under a microscope? Nah, doesn't work that way, does it? How about that? That's a tendon. Tendons are very interesting, especially in this darker kind of microscope use called polarized light. Okay, let's do something real quick right here. Let's everybody stand up, stand up, stand up, stand up. Shake your booty. Come on, I don't see any shaking going on. That's it, shake it. All right. Have a seat. Have a seat. How you guys doing? Everybody okay? Am I boring you yet? I hope not. Anybody in this group want to become a microscopist when you grow up? Look at that. Yeah, Daddy does. Now, you had a question back there. 1 second. Yes.
Hey, you're asking all these questions about how things preserve. Can you answer them now?
Okay, I have a challenge from the audience to answer how these things are preserved. The other folks, let's call them, say that the iron preserved these things, but they're very specific. They only say, we've only tested blood vessels, and we've only proven that iron helps the blood vessels last a little longer, and maybe, just maybe, they lasted 68 million years this way. That's their answer. That's the only answer being given from the other side. Now, you're asking me what my opinion is about how these are preserved. I still have to say, I don't know. I think that God is involved in this. I think that He has left these things in the ground for us to find right now at this time. Can you think of a more important time in our history? Look at what our country is going through right now. Yeah? Cancel culture. This mandate, that mandate. We do this because we say so. Is that the country we grew up in? It's not the country I grew up in. You used to be able to vote here and have your vote counted. And yeah. So what better time than right now when everybody's upset, ticked off, angry, frustrated, lost job, lost money, lost this, everybody's lost something during this, haven't they? All of us have. Some of us have lost our wits. I still can't find mine. But what better time to say to people, God is in this, right? Do you think that's a bad answer? To tell people, I think God's in this? I think it's a good answer because people need to face God right now. If this is not a bowl of wrath, what was just poured out on us, I don't know what was. And you know what? This flood was real. It killed everybody, right? This flood killed everybody and everything that was air-breathing, land-dwelling. Yeah? And what does he say? There's another what coming? Another judgment, not a flood. What is it? A judgment by fire. By fire. Read 2 Peter 3. Everything is going to burn. All your possessions, everything you've worked for, is going to burn. That's a judgment. Why? God's angry. God's upset. We're aborting millions of kids in this country every day. Okay, question.
If the flood was water, wouldn't the sea dinosaurs still be alive?
If the flood was water, wouldn't the sea dinosaurs be alive? Can you prove there's none of them alive right now? I can't either. What if in some deep water body, somewhere in some strange part of the earth, there's something living there that we just haven't gone to see yet? I don't know. Yes, sir.
First of all, I like the deep sea a lot, and there's not much known about it, so there is a good possibility that they
Yes.
could be there. The second thing is that the reason that most of them are probably gone is that the Bible says that the earth itself opened up
Yeah,
and gave out water.
it did. I hope you all can hear him. Can you hear him? Okay.
If the earth cracked open, let out water, the immense pressure of that would not let many things that were near it survive.
I know a lot of people didn't like the movie Noah, but there was a shot in that movie where these supersonic jets of water shot out from the earth based on the pressure that they were under, right? Can you imagine living next to that happening in your neighborhood? You wouldn't live long, right? Okay, I saw another question back here, real quick.
If all the countries, when all the countries were put together a long time ago, was there anything on the other side of the earth?
Well, I don't know, because I wasn't there. All I know is God said, let the dry ground appear, and it was so. And God said, and it was so, and God said, and it was so, and God said, and it was so. 6 times he says that, right? Why? Because I'm thick-headed. And he needs me to know that he said and it happened. Question.
I think that you were right about him preserving those bones for a purpose. Because right now, as my mother would say, the earth is kind of inflating.
Yeah.
He needed help.
Yeah. Everybody needs help, don't they?
The only person that can really do that is God.
Amen, sister. The only person who can help right now is Jesus. That's why we're doing this, okay? The science is beside the point. We do this science, why? It shocks people. I get a chance. Let me give you an example. Can you hold on to your question for a second? Don't forget it. Promise me? Let me give you an example. When I started this, hang on to your questions for a minute. Let me just tell you this story. This is how I started this. When I was in a grocery store line, and there were a lot of people in line with me, as soon as the cashier said, "How you doing today?" I said, "I'm doing great. I went on a dinosaur dig." You know what that does to a line of people behind you? What? He went on a what? I want to go on a dinosaur dig. Who? You know, I got their attention. That's what I like. Why? Because I'm a gabber. I like to talk. And I want people's attention. Everybody wants to go on a dinosaur dig. So I say, yeah, we went to Montana. And the cashier's trying to do her thing. But I'm not talking to her. I'm looking at her. I'm not talking to her. I'm talking to everybody standing behind me. We went to Montana, and we found a 48-inch long Triceratops horn. And I do it just like that. Why? They're remembering this moment. Yeah? You got to act it out a little bit. Big horn, and you know what? It was full of soft tissue. And I squeezed my arm. When I turn around and look at those people that are looking at me, they're like this. Because they just heard a guy say he went on a dinosaur dig and he found soft tissue in a bone. And wait a minute, didn't they tell me those things are old and dusty and dry and there's no, what? You see? This is the hook. I can get to Adam and Eve in about 30 seconds after that. Yeah, that means the flood was real because it's all full of soft tissue down there. The flood must have been real. Must have been a short time ago. And so maybe Genesis is true. Maybe we really did come from Adam and Eve. And you know, we made a T-shirt with the Band-Aid logo, all the different colors of the Band-Aid, and we wrote Adam plus Eve equals. All the Band-Aid colors. All the colors of the human race, one race, one race. We are one race, one blood is what it says. They're not races. Don't let people talk you into thinking there's races. We're one people. We're all from Adam and Eve, all of us, okay? I can get to that in 30 seconds after I squeezed my arm. Now I've preached the gospel to them, haven't I? Using dinosaur soft tissue. That's why we make these books. We make these so you can do that. You can give this away. If you need more books, we will get you more books. This is not to sit on your shelf or on your desk at home. You give these away after you read them, yeah? Question. And then I'm coming to you. Question. I'm sorry, real loud.
So back to the question when you said to lick the bone.
Yes.
Wouldn't you get rabies or any diseases?
You know, I was out with my pastor and his kids for lunch one time, and one of his kids was a hypochondriac. She was afraid of touching anything. And I was about to eat my vitamins for the day. So I took my vitamin pill, especially my fish oil, and I grabbed the pepper shaker and the salt shaker from the table. That how many people have put on their food? Yeah? How many people do you think had touched that salt shaker? I rubbed my pill all over that while she was watching me, and then I swallowed it with a drink of water. Nothing happened to me. I have good stomach acid, but she was freaked out forever. So I don't know. Can you get stuff from licking these dinosaur bones? I suppose it's possible, but it hadn't happened to me yet. You, sir. 1 second.
How did the dinosaur bones get buried?
How did they get buried? Great question. How do these bones get buried? When we find these bones, they're mostly ripped apart. So we think they were kind of in a cement mixer of mud as they were going along. Look, if supersonic jets of water were shooting out of the earth, as we discussed previously, right? And water was falling from the sky, and the whole mountains were covered with water, I would think everything would get covered in dirt pretty quick. Yeah. Have you ever been in a flood? Have you? Was there a lot of mud? Yeah. See? Even the little dinky floods that we see have a lot of mud. Okay, somebody over here had a couple of questions, and I'll come back to you. Yes, sir.
So your answer to one of Eddie's questions that God was involved in preserving them, couldn't you use that answer to defend both the young Earth and an old Earth viewpoint?
Couldn't I use it as?
Like to defend young Earth and old Earth?
You can, but again, that goes back to arguing with people. And, do we really need to defend God? He's pretty strong, and he can defend himself. Our job is to testify, right? And so my advice is get your story. I have a story. You guys can have this story. Make it your own and share this story. Come on a dig. There are tons of digs. You can go on a dig. Try this yourself. Make it yours so that now you're giving yourself away to people. That's what people appreciate. They can tell when you're pushing them, selling them on something versus giving yourself away. You see the difference? So if you're arguing, stop, please. Okay, yes. I shouldn't talk about this stuff, should I? How many bones have I licked? Probably a dozen. I got tired after a while, but I prefer the tap method. I think that works better. Okay, one more question, then I'm going to continue.
If there are dinosaurs and stuff a long time ago, if there were, then
Louder, please.
there are only a couple accounts of these in the Bible.
Yes.
That is true. Are there any others?
Other accounts in the Bible? Well, I'm only familiar with Behemoth and Leviathan, right, in Job.
Yeah, in Job chapter 41 to 42.
You know it.
My favorite chapter in Job.
Good for you. Yeah. So, I don't know. I mean, I'll tell you one thing. The Lord is a biologist. As a biologist, I can tell you, we're biological organisms. He's a biologist. So I know he loves the dinosaurs. Okay, so those are tendons. Remember, we're in the Permian, right? Here's what I wanted to show you. This is a bone. I'm not going to tell you what kind of bone because it's still a secret. But it's a really interesting bone. I'm thinking of all kinds of fun names of describing this in our papers. But you're going to love it when you find out what these bones are. This is a bone that has sat in that weak acid for only a couple of days. And I want you to notice something. First of all, you see, obviously, all these things sticking up. Okay? These are tendons. Some of them are vessels. A lot of them are tendons. Here's a vessel that has a big red blood clot in it. Can you see that? Yeah. Remember I talked about clot canopies? That's a clot canopy. That's a clot at the end of the vessel. Here's another one. You're going to see more of these. Clot canopies are where the vessel, the clot, actually went into the capillaries, and it made a canopy on that stalk of a vessel. Isn't that cool? We're finding some interesting things. Here's a tendon, just a raw tendon. It's like a polymer. It's like a plastic. It's a rod. It's just like a retaining rod in the bone to give it. And I wish I could tell you what bone this is, because you'd be fascinated at what bone this is. Here's more canopies. There's a canopy here. See that one? That one? That one? But look at all these holes. These are all the canals, right, class? And these things are sticking out of the canals. Some of these might be nerves. You have to pull them out and test them. Look at this winding vessel. Fully clotted. Fully clotted. Still clotted. Another canopy, close-up of a canopy. Okay, you have a question.
How big are those? Because how big is the tendon? Like, is it like there are obviously some that like there are some that's attached to your leg that you can move your foot, but
Yeah,
those look like microscopic.
they are. These are microscopic tendons because we're dealing inside the bone. Things get really tiny when they get into these tiny canals. I'm getting tired. Yes. Yeah. Sorry. Question?
When are you going to be releasing your work?
Well, we have a paper in publication right now on Dimetrodon, which I'm hoping to show you if we ever get to it. What time is it now?
2:13.
Yes.
I just wanted to clarify that when we talk about tendons, we are talking, like, when we say, oh, my tendon hurts or my tendon's stretched, we're
Tendinitis.
talking about tendonitis. We're talking about where our outward, like our tendon, where our bone is attaching to a muscle, there's a tendon between that. What he's talking about is inside the shaft of your bone are also small tendons that attach your bone to the inner parts of the vessel.
I'll tell you what these are. These are toes. So imagine the pressure. Don't tell anybody, please. This is a secret. This is a real secret. You know why? Because the other team is going to jump on this, and we want to be the first ones to publish. So these are toes from hadrosaur. This is a big animal walking on toes, and they're putting all that weight on there, so they have to have the exact structure you're talking about.
They have to have the internal integrity, so the bone is, there's a space in the middle of the bone, so the bones are light enough that we can walk around, but strong enough that they can bear all the weight.
Fantastic. Thank you. Great point. All right, let me move quickly, and then we'll take some more questions, okay? Do we need to stand up again? No? All right, 5 more minutes and we will. So, that was Eriops. This is K-Cops. He's the small guy, 6 inches long. What do we find? Cells, nerves, lipids, fat. We talked about fat, clotted vessels, and more. So here we go. Again, look at those beautiful cells. 290 million years old, supposedly, yeah? We don't think so. Here is a nerve now, and you can see the crosshatch pattern. Not so much when it's blown up like this, but if you come over to that microscope, I will show you nerves with crosshatch pattern. In fact, I'll put it on the screen before we end. Here's a fascicle. This is a little liberated fascicle that came from inside one of these guys. Look at all the stripes in there. This is also a diagnostic feature, but you can see the crosshatch pattern. Do you see it clearly on here? I prepared a bunch of decalcification slides, and I sent them to a fellow microscopist down in Southern California because I didn't have time to screen them, and I asked him to screen them and take pictures. He took this picture, and he said, unknown fiber. No, I know what this is. That's a nerve. That's a nerve in a 290 million year old organism. Now here, you can see the crosshatch. See it? We know it's a nerve. Got crosshatch. Look at that. Look at that. Those are lipids that I stained with another stain, and it turns them a little bit black. In fact, if you put fresh tissue in this stain, they turn really black. But these did what? They turned gray. Those are lipids oozing out of this Permian nerve. Okay? Here's a clot this is a thin section now. Much like I showed you before, there's a clot in a canal. So K-Cops has all this stuff. So again, I talked about this morning. A forensic scientist in a laboratory said we are only finding cellulose fibers, but we compared them. So we collected a bunch of cellulose fibers and did a comparative study under polarized light, and they look nothing like the nerves, right? So we know we're finding nerves. But I love these kind of challenges. When I get a challenge like this, I go, challenge accepted. Why? I can put this in a paper now, see? Because somebody said, no, those are cellulose. We don't think so. Okay, all this work was, well, let's see. This is fresh material. So all that work before were bones that we collected from a museum. They were in a museum drawer. Okay, this is now fresh. That's a fresh K-Cops nerve. See it here? See the crosshatch? Look at how beautiful. You can see the fine detail in there. So that's Permian. The preservation in the Permian is better than the preservation in the other stuff. Here's another beautiful crosshatch pattern. And I don't know if you can see these little lipids here. See these lipid droplets? Oil floats in water, right? So they're coming out and they're wanting to go up to the top of the water. Okay. Dimetrodon. This is the guy in the picture in the beginning. These are pieces of his femur that were laying on the surface in Oklahoma, Lake Frederick, Oklahoma. And we also found jaw. So here's the femur. I've already cleaned away a lot of the debris. But this is right on the surface. I didn't have to dig this up at all. And here's the jaw. Let me see. See that? Here's the jaw. That's the jawline. And here's a tooth here. Here's a tooth here. And there are other teeth in here. So we thin-sectioned these. We actually thin-sectioned the teeth also. Here's a better picture of the jaw. See the tooth? Wait. See the tooth here? Another tooth here. A couple of other teeth in here. Laying on the surface. How is this possible? You have a question?
So how do you find like little pieces of bone? Like do you go around licking every rock that you find, or?
Well, I gave up licking, but yeah, I mean, you literally, if you look at the surface here, a lot of these things are mineral concretions, but some of those little tiny black bones that I showed you, they're laying on the surface here. So you have to search, you have to search on the surface because it's really hard to see. I think my laser's dying. Okay, so we thin section the femur, remember? Half the width of one of your hair, thin section. And what do we find? Clots in the canals. There's a clot. This is calcite. So what does this mean? This bone was permineralized. It became solid rock. There's no soft tissue in this bone. It's all fossilized, permineralized. So you can see where the calcite came in and filled in around the bone canal. But here's, what is this? Is it a clot? Is it a clot? I don't know. Let's put it under UV. Oops! That's a clot. That's a clot. Okay? Look at the one on the right. See the iron? Iron starts to glow. Here's another one. We got a red arrow that shows that the clot, this clot is descending down in here. That's what the arrow is showing. This is going into the bone, yeah? Clot's going into the bone. We just shaved it thin. The black arrows, they show that the clot did not leave the canal. It's in the canal. Same thing we saw in the Triceratops, right? Look at the guy on the right. There's a nice, this is a rib. That's a nice clot on the rib here. Let's put it under UV. Look at that. Look at the scratch marks in it. Why does it have scratch marks? Because it's metal. And you can scratch metal when you polish it. Yeah? You see that? Those are polishing marks right here. But look at that. That's all, the whole thing is almost solid iron. So folks, we're finding this in Dimetrodon, in many, many organisms, and the work is yet to continue, and I need workers. So, okay, we're going to do more questions? Yeah, question. Can I show you the what? I still can't hear you. Do I have the Dimetrodon bone to show you? Did I lick this one? I'm losing it here. You want me to lick a bone right here, right now? All right. How much you got in your pocket? How much you got in your pocket? You want to do it? Somebody wants to volunteer. All right, we'll do that in a second, and you're elected, okay? Okay. Question, Mom. Shh. Great question. When was soft tissue first discovered? In about 1997, Dr. Mary Schweitzer of North Carolina State University started finding fragments that she didn't recognize. And so that's when her work began. Her most important publications came in 99, 2000, 2001. I published my first paper on soft tissue in 2000 in the Creation Research Society Quarterly. But the new work is miles ahead of what they've done. Let me just take a second to talk about how folks like Dr. Schweitzer are going with this. They've gotten away from larger structure. They're looking at molecules. And I think they do that in a way to confuse people, because molecules are hard to understand, at least for me. I don't know, maybe you really get molecules. They're hard for me to conceive of. And so they're looking more in molecular paleontology, and they're kind of ignoring this whole area. That's why I think we were able to find the nerves before anybody else, because they kind of ignored it. So it's recent. It's only been in the literature since the early 2000s, and here we are 21 years later. So there's a lot of work to do. Question?
What is the oldest tissue and how long does it last?
Well, this is the oldest tissue I've ever found, that nerve. 290 million years old. I mean, how long does it last? 290 million years. Or so they say, right? What am I supposed to believe? Somebody tell me what to believe. Okay, question.
So you hear about like dinosaur fossils a lot, but what about like human fossils or like a raccoon fossil?
Great question. Why don't we find a lot of human fossils? Anybody know? Anybody know? Dust you are, and to dust you will return. I think God gives us clues in scriptures. Now, when he talks about the behemoth, and he talks about the Leviathan, he talks about their bones, doesn't he? Doesn't he brag about behemoth's bones? Aren't they like brass? He says, right? You read that in the book of Job, right? Where did you go? My Job lover. He's over here. Tell me, what does it say when it talks about the bones?
I didn't read all of it.
Okay. You look it up, okay, when you get home. Guys, do me a favor, look it up, because he talks about how those bones are like brass. I think God is giving us clues in his word about why these things are so well preserved. Yes, dear?
How can you tell how old the tissue and bones are?
There's no way to tell how old it is. You cannot measure age on a soft piece of tissue. There's no clock. I mean, they guesstimate about how long it takes for collagen to break down. And they've decided that it takes 1 million years for one collagen fiber to go to nothingness. 1 million years. That's a pretty sturdy fiber, right? I think God did a good job making that fiber if it's going to last 1 million years. Just because it can last 1 million years, just because it's really engineered well, doesn't mean it's old, right? It just means the creator used the best materials available, yeah? He designed a good collagen molecule. So there's no, look, if you can live 1,000 years and start an experiment on day one and end your experiment on day one of year one, and end your experiment on the last day of year 999, and then publish in your 1,000th year, you will have some data to share. But nobody lives that long. So how can you do that experiment? So no, it's impossible really to tell by looking at a piece of soft tissue how old it is. All right, I'm going to go to this side, because you guys have been getting a lot of questions, right? Haven't they? Let's do this side for a while. We love you. We do. We love you. But yes, ma'am.
You were talking about finding blood clots once in dinosaur bones. What percentage do you think of bones have blood clots?
The ones that are not, great question. What percentage of the bones we're collecting do I think have clots in them? I would say probably 95%. The ones that don't are the ones that are heavily permineralized or have been left on the surface and decayed further or were eroded more deeply. But the stuff that's buried in sand, and this stuff is literally buried in sand. One of the guys, have you guys seen the show on Discovery Channel called Dinosaur Cowboys? You haven't seen that? There are these two guys, these two brothers that dig dinosaurs in Montana. They're ranchers, but they've learned to sell the dinosaur bones that they collect on their ranch. Well, we dug with those guys. Those are the guys who we dug with. So we've seen a wide variety of the bones that are really well preserved in these sand pockets or laying on the surface and decaying. So great question. Yes?
So I've heard that like when a dinosaur gets buried, over the influence of like running water on top of it, like bits of minerals will like smash away at the bone and replace it with like rocks and minerals and stuff. And like in your experience, do you think that's true?
Yeah, did everybody hear his question? His question goes to permineralization and how it works. And we saw that in the Dimetrodon. See? Remember, this is calcite. So this is infiltrated from the water. The water was super saturated with this dissolved mineral. It leached into the bone, and then it hardened, right, when it dried out. So this is hard crystal right here. As far as, what was the rest of your question? Repeat your question again, because I forgot.
When a fossil gets buried,
Yes.
like under the influence of running water, will
Yes.
it like smash away at the bone and replace it with minerals and stuff?
Yes. Water does two things. It can infiltrate with the calcite and do mineral replacement. So what happens there is the biological molecules, we talked about molecules, they get replaced with mineral molecules, but the shape is exactly the same. It's just frozen in crystal, right? That water does, but water does another thing. Water erodes. So it can erode the bone or it can infiltrate the bone. The thing is, there's just such a wide amount of circumstance variables. There's so many variables involved with what's going on here. That's why I need workers. Come figure this stuff out with me, okay? Yes.
Well, I was also looking at a timeline that we had based off the Bible, and I can't tell you 100% true, but I did some math, and I calculated that the Earth is somewhere around 7,500 years old. And
It's reasonable.
I've heard that, like, when the flood actually happened, in like the supersonic jets of water, that caused like massive landslides and buried animals, and
Yeah.
buried them alive. Because we were reading a textbook, they actually had a fossilized, I'm not sure what it was, but it was giving birth.
Absolutely. Yeah, there's fish been caught in that action of giving birth. There's a fish that was found half eating another fish. Yeah, this stuff happened pretty quickly. So we have no way to know. We weren't there. We didn't see it. I'm sure it was terrifying. I think somebody was talking about the pressure that happened as a result. You realize 20,000 volcanoes were going off in the Pacific at the same time, right? You realize there's 20,000 extinct volcanoes on the floor of the Pacific. Just the shock from those things going off alone probably gave people heart attacks, I would think. Yes, dear? You forgot. Hang on. Keep working it. Yes, sir. Do you remember it? Okay.
Like, how do you find the places that you dig?
Great question.
Like, choose them?
We do not randomly choose the dig sites. This is an important question. We do not randomly choose the dig sites. We go to dig sites that other scientists have gone to and have written about in the literature. Why? We want to reference that in our paper. We have to read all those papers, read all those studies, look at what they found, talk about that in our paper, and then show how our work is equal to or superior or whatever. But yeah, no, you have to read the technical literature. That's really important. Do we need to end? Oh,
I'm going to give some of the kids who need a break.
okay. We're going to take some time to have a break.
Okay. You can keep thinking of questions, and Dr. Mark will keep answering, but I also know some of you, maybe you're just visiting or haven't had a chance. Hybrid kids and really, and other guests and visitors, there's a series of exhibits set up across the hall that have all kinds of different dinosaur activities, information. Mrs. McHenry's. Yeah, the audio is piped in over there, so you can continue listening. But Mrs. McHenry is going to be over there explaining the exhibits, answering questions. But we're going to continue to have question and answers over here. Dr. Mark is going to put up a few specific slides, have a seat, have a water, but we're going to keep calling on people, and then we're just going to go all the way till 3 o'clock. So if you need to use the restroom, or you would like to see some of the extra hands-on exhibits and the exhibits that Mrs. McHenry has, this is a good time to excuse yourself, quietly excuse yourself. And then if you want to slip back in, that's fine. Q&A will continue. You can wiggle your arms a minute. If you have questions for Dr. Mark, remember them in your mind. We're going to keep going. But he can say sitting, and I can even, that's fine, and I can even help you moderate who the questions are coming from. Any housekeeping questions? Restrooms, ladies' room is here. If you don't, if the family restroom is full, the boys' room is at the bottom of the other stairs. Yes. You know, any of the guests, there's about 5 or 6 exhibits in the other room. The audio is happening over there also, and a video. The Altoona kids, I'm sorry, what are you guys called? Arrows. Up to you. But if you just need to use a restroom and come back in, that's okay also. All right, so keep thinking of your questions. We've had a lot of information, but Dr. Mark's going to be able to continue answering all the way through 3 o'clock.
How much time do we have?
You about a little less than half an hour. Maybe let's say 20 minutes, and then the fuzzy time.
Yes.
So you can show, you can go from here.
Yeah. Okay, perfect. Thank you. I'm going to blow my nose like an adult.
You know what? Everybody take a 3 minute.
Hybrid needs to go downstairs at 3 o'clock.
Yeah, like so. Yeah, so the hybrid kids, we are going to dismiss you downstairs to collect your things and leave. I'll tell them on the microphone because they can hear me. So if you're in the fellowship hall and listening, the hybrid kids, I am going to dismiss you at about 2:58 to get your backpacks. Oh, no, we need to get books.
Want to bring them back in, grab book, go back up? No?
Hybrid kids are going to be here. But, okay, if you're a guest or from Arrows, or you're still, everybody can get a red and a green book today. Why don't you go ahead and do that?
Spread them out a little bit. Go ahead. Go. Excellent. Get your green, get your red hot peppers. I don't know. I'm trying too hard, aren't I? All right. There you go, guys. Grab your books. This is a real-life Triceratops nerve on the microscope. You see the crosshatch? Yeah.
Can I look it up? The restroom. I can tell my mom I looked at Dinosaur Cowboys. Did you look it?
Does anybody else have any questions? Come on up to the front and come on up. There you go.
So remember how the guy there said, like, all the pressure from under the waves, it would have killed the probably would have killed off a lot of the dinosaurs in the water. Have people found very many fossils under the ocean that are like on the ocean?
That's a good question. They've done deep sea drilling, but I don't know if they've ever found any fossils down that deep. I think most of them are pushed up to the surface at this point.
Or do you think some of them might have gotten like smashed up by the pressure?
You have questions, let's sit back
I mean,
down.
what if
We're
they
gonna go back into Q&A so
fossilized
that
and
everyone
went
can
down
hear
there, went in the mid-ocean?
the explanation.
Yeah.
Anything's possible, right? Good question. Good point.
I will run and have a question and then run it back to you. And then if you want to, I don't know what you're doing.
Well, I put a nerve up there. That's about the prettiest nerve I have with me.
Okay, if you have a question, please raise your hand and I will get the mic to you.
So why are all of the nerves, like all the pictures you showed us, just like segments of the nerves? Did they, like, is that how you found them, or?
Great question. The question is, why are all the nerves like segments of nerves? And the vessels are the same way. We see a lot of segments of cells. A lot of the cells are fractured. So it's a whole range. You'll get beautiful cells. You get clusters of cells, like I showed you, all the way to just cell debris. So there's a whole range in that. The nerves are the same way. They come out in fragments. Remember, this is all decal. So all this stuff has gone through that weak acid and fallen out on the bottom of the Petri dish. With the Permian stuff, and I think we have some videos loaded. Maybe I can show you guys. And I can definitely show in the workshop. I'm pulling nerves out of the Permian bones. So they're not falling out. And I have one video where it looks like a rubber band. I actually grab it with a real fine, I use these real needle forceps. They'll go straight to your bone if you push them hard enough. And to pick these things up. And I have a video of me stretching a nerve. So I want to show you that one. And this one where I tug on it and it stretches and then it pops like a rubber band. And so I just replay over and over. You can see it pop, 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 because it stretches and it pops. So you can see that it's under like tensile strength and then it breaks. So this stuff is crazy. And I see this stuff and I hopefully have cameras running to capture it because I see this crazy stuff all the time. A lot of times my cameras fail and, that happens.
Peyton had a comment.
I have a couple of questions. The first one is, whenever
Come up front with him so you can just hand it to him.
whenever Mary Schweitzer, whenever she found the red blood cell, didn't she say like it wasn't the actual cell, but it was something that actually looked like it?
Let me rephrase your question. The question is the terminology that she used to describe what she's seeing. Scientists try to be really careful in not over-explaining things or jumping to conclusions too quickly. Even though it might be terribly obvious to you and me, if it's a red blood cell, she called it a red blood cell-like microstructure. Yeah, she's using her terminology to couch it in the way she wants you to perceive it. We don't do that. We just say, hey, that looks like a blood cell. Hey, that looks like a vessel. Hey, that looks like a nerve. And we publish it, and we wait to hear from them. They're silent. They don't really come back to us with anything. So you're right. And it's sad that people do that. It's sad that you have to put meaning, your meaning, into a fact. Let's just let the fact be what it is and let everybody come to their own meaning, right? So you are astute. You found a really big problem in science. Oh, yes, you have another one. Sorry.
Another one is, what do you think on Behemoth and Leviathan?
I'm sure they were dinosaurs. I'm sure Behemoth and Leviathan were dinosaurs. I'm really curious about the sparks coming out. I've never seen that in biology. So I'm like, okay, how does that happen? I've seen bioluminescence. I've seen autofluorescence. But I've never seen actual sparks of fire being created by a biological organism. So I did study the bombardier beetle. Some of the creationists talked about sparks coming out of the bombardier beetle. That's not true because there's high-speed films you can see, and it's all vapor coming out. So, yeah, I mean, Leviathan is trippy. what was he? You know, it talks about if you try to put him on a leash, you'll never forget it. Yeah, so I don't know what was he, but I can't wait. I can't wait for heaven. I personally believe there's going to be an Eden 2.0. Isn't that what it says? Now, if dinosaurs were part of the creation, wouldn't he make them again? Why would God abandon something that was good? Very good, he called it, right? Why would he abandon something that was very good just because Satan came in and messed it up? He's going to redo, I think. So I think we're going to see these creatures. Another one?
Perfect timing. I was reading Psalm like 4 or 5 days ago, and it said, it doesn't say that it says that only God can crush the heads of Leviathan, not just head, but heads. So would you think that that was like a multi-headed creature?
Know. That's trippy. That's Psalm what?
I forget. I think it's like in the 60. I read from 60 to 85.
Text it or email it to me because I want to look at that.
I will.
That's trippy. I have not heard that. Crush the heads of Leviathan. It's plural.
I didn't, like, it was saying how powerful God is.
Yes.
I wasn't like thinking, okay, this is what I'm reading, because I knew it was there. I was just like reading a random.
It's fascinating. I've never heard that before. Send me that, okay? I got to look that up. Any last ones?
I think that's
All
it.
done. Okay, yes, sir. Come on up. Come on up. Come on up. You got questions? Come on up. Go ahead.
So you found nerves, and what did you find in the nerves? Did you, like, you found blood clots in the bone canals? Did you find like blood inside the nerves?
No, we have not. That's a great question. Have we found blood inside the nerves? You actually have asked a very important question because there is blood supply inside this. I haven't seen any clots in the nerves, but they're still really soft and covered in fat. What we have found, I have found vessels adhering to the outside of the nerve. So I have pictures in my files of blood vessels traveling along the outside of the nerve, but I've never seen any clots or blood inside. I think, I read about in Alaska, the Lipscomb Bone Bed. Has anybody heard of the Lipscomb Bone Bed? It's a bone bed in Alaska that's in the permafrost. So it's been frozen since the beginning. Yeah. We'll talk about the tar pit because I used to live there and I went into the tar pits and yeah, that's a good point. We need to talk about that. But no, I think they're frozen in place. I was reading the other day about an observation that scientists made decades ago where they found a frozen river with frozen fish in it, just frozen in place. So I don't know if that goes back to the flood, but I thought, wow, that's pretty trippy right there, right? But if we can go to Alaska and dig in this bone bed, I think we will find frozen remains that are going to be much more intact. Because all this stuff looks like it went through a cement mixer. It's all jumbled up, broken up, torn up, smashed up. You do find some articulated skeletons, but they're kind of rare. So I can't wait to go to Alaska and try that. Come on up, dear. You got to come up here to ask the question. Okay.
All right, so have you found DNA in any of this?
Have I found DNA? I have not found DNA, but I have found RNA. And I could show you a picture. I'll try to find it. When we collect tissues off the bottom of the plate, sometimes we find, I'm having a senior moment. Welcome to my senior moment. It's fun for me. I don't know about you guys. We find veins. Now, veins are different from vessels, right? Vessels are hardier. That's where the blood comes out of the heart under high pressure, goes through the vessels, right? That's high pressure stuff. The veins, that's low pressure. Why? It's coming back to the heart. So there are valves. Did you know that? There are valves in the vein. They're called venule valves. They're really hard to pull out of like your veins. If I wanted to get vein valves out of your veins, I'd have to destroy the whole vein. They're falling out of the veins onto the bottom of the plate. Okay, can you picture that? They're round. I'll try to find you the picture. They're perfectly round, and they have two cuspids, just like your heart has cuspids in the valves. These little valves have cuspids. Why? When the blood comes up, the cuspids close, hold the blood in place till when? The next heartbeat, because it's low pressure. So they wait till the blood starts to move, then they open up, the blood moves, they close again. They're valves in your veins. We have found them on the bottom of the Petri dish with both of the cuspids still there. I actually have video of a vein valve that I stained with an RNA stain. Excuse me. It's glowing orange, meaning, hello, I'm RNA. So we did find RNA, but inside that closed valve, there's water, and there are bacteria swimming around in there that came back to life as a result of me putting water on these bones. Bacteria go into a spore stage. You know about that, right? When conditions are bad, all the bacteria go, oh, I'm not going to survive this, and they make a cyst, and they can live in that thing. In fact, they've made beer from yeast that was found in some of these old vessels in the tombs in Egypt, in some of the pyramids. They're now making beer from that yeast. So the yeast, these organisms can last a long time. Anyway, the whole point is this. I have this video of this vein valve with bacteria swimming around in it, and they're orange too. Why? They took up the stain just like the vein valve did. I'll try to find that video. Does that answer your question? Okay, come on up.
Yeah, so is Jurassic Park possible where you can make new dinosaurs or something like that?
I hope not. I don't want to see Nano Taranis on my street. I don't think so. I think the DNA is too degraded. A paper came out a few years ago, and they said the half-life, okay, what's half-life? The amount it takes for half of your substance to break down into something else. That's all half-life is. The half-life of DNA is 521 years. So after 521 years, half of your original DNA is already decayed and gone. It goes away fast. So I'm not sure we're going to find DNA.
What's RNA?
RNA, good question. Deoxyribonucleic acid is DNA. RNA is ribonucleic acid. Ribonucleic acid, you've heard of the vaccine, yes? It's an mRNA vaccine. It's an RNA vaccine. It means they're injecting us with genetic material. It's called gene therapy. Anyway, don't get me started, right? RNA is an instruction. It's a copy of the DNA. So in your nucleus, when your cell says, I need more of this or I need more of that, it goes into the DNA and makes a copy, carries out the copy. The original stays in there, right? That's the vault. The copy comes out. That's RNA, and that's what makes your proteins and enzymes. So RNA is nuclear material. Come on up. Over here. Yes, I'm leaving you behind, aren't I? I'm so sorry. What's your name?
My name is Hayden.
You're right. Hi, Hayden.
So my question was, have you ever cut a bone in the wrong direction before?
Yeah, I've said, oh, I shouldn't have done that. I've ruined lots of bones. This is what I do. I ruin bones. Most of the paleontologists hate me because they're like, you're going to destroy this beautiful thing, aren't you? Yeah, because there's soft tissue in it. So I have broken many bones and said, oops, be careful with a Dremel. I'll tell you that. You know what a Dremel is, okay? You watch your fingers. Yeah, and off goes a chunk, right? Yeah, it'll embed in your eye if you're not careful. Wear a pair of glasses, yeah. Any others?
Nope.
No? Good question, thank you. Anybody else? Yes, sir.
I have two questions. One,
It'll come back to you.
how do you, if you can't prove that the cells can't decay in like however many thousands of years, like 7,000 years or something, then how can you say that they couldn't decay over 1,000,000 years either?
Yeah, that's a good question. I mean, you're asking about unobservable time. How do you document unobservable time if you can't observe it? How do you document what's going on? This is our problem. We're finite creatures. So a lot of this is by faith. The Geologic Column, that's purely by faith. And even the textbooks will tell you, you know what I mean when I say the Geologic Column, right? This is in the geology textbooks where they show you this layer and this layer and this layer. It's in our book. If you look in the red book, you'll see the geologic layer. And this is what they purport to be actual history. They say this layer formed, and then a million years later, yeah. So this is what page number? So,
Page 10 in the red book?
so look on page 10 of your red book. Look at that diagram. And you'll see several things. You'll see fossils cutting across some layers. We drew some trees in there, cutting across some layers. That's called a polystrate fossil. It means it goes across many layers. Why was the tree that patient over that many million years to wait and not decay while the layers came up around it, you see? No, these didn't form this way. Everybody thinks the layers form this way. I've seen video of them dropping different sand grain colors and size into a flue of moving water. That's what a flood is, right? It's a flue of moving water. They dump it over here, and you watch it form this way. The layers form together like that. So we think we know how the flood could make layers. We don't have a clue. Does that answer your question? Another one? You're asking the toughest questions, which is good. Because if I'm wrong, I want to be proven wrong. Yeah. I don't have an axe. I don't have a dog in this hunt. Okay? Except Jesus. He's the only one I have in this hunt. If I'm wrong about this, I need a scientist to tell me right now. So far, nobody's said anything. So, but your questions are good. How do we prove if we think it can't decay, if we think it cannot decay in 4,000 or 7,000 years, your question is valid. Why do we have to think then that it might not last a million years? Well, we already know collagen, they say. Nobody's watched it. If you sat around for a million years watching collagen, that would be boring to me. That's like watching the grass grow. I don't want to do that for my life, right? I'm being funny. Apparently not. Anyway, the problem is observation, isn't it? How do you extrapolate? And this is what Mary Schweitzer did. She soaked some blood vessels from an emu and an ostrich in purified blood. But what did she do to the blood? First, she put an anticoagulant in it. Yeah, you heard me right. She took the blood that she was going to soak the blood vessels in, and she put an anticoagulant injected into it to keep it from what? Clotting! Because why? Blood clots, yeah? You get a leak in your vessel, it sends a signal to other cells and enzymes in there, you have a leak. And what does it do? It clots. You get a scab, yeah? So, we can see those things operating in biological systems now, but we have no clue about what happened in the past. But anyway, I think I'm rambling. Did I ramble too far? It's okay to say yes.
The answer is you have to believe, you have to have faith.
It comes down to some faith at some point, doesn't it?
One more question here, and then we're going to go to, did you have a second one? Yes.
I feel like I'm inadequately answering these questions, but I'm trying.
You're doing a great job.
Okay,
We think you're doing a fabulous job. All right, did you have another question?
Yes.
All right, go ahead.
So can you pull up a picture of the clotting again?
Okay. Well, there's a clot right there.
So turn it to black and white. Thank you.
Oh, that's right. This is the part where my brain doesn't do signal. Thank you. There, that.
So what is the clot and what is the blood?
The clot is everything inside the canal. Okay?
The white stuff or the gray stuff?
The white stuff. So this is a canal. This is a canal. There's another part of it going this way. Sorry, this pointer isn't so bright. That's canal. This is bone. So this is the hole in the bone where the blood vessels were, right? And you can see the iron because it's reacting to the light. I'm shining a special light on that iron and it's glowing, saying, I'm iron. I'm using 240 nanometer wavelength. Does that mean anything to you? It's UV. If you stare at it with your eyeballs, you'll burn off your retina. That's how strong this light is. But look at how it lights up iron. Does that help?
And then the dark spots are blood.
Well, maybe this is iron that's, let's get the pointer going here, can't see it anymore. Maybe this dark stuff is blood that's not at the surface and it's not reacting to the light. Maybe if my light was stronger, it would shine down in that hole. I don't know. I have to do more experiments to figure it out. But every time I slice these things and I look at that clot with that lights up every time. So that says iron, 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 iron. So I got to figure that's the iron from the blood. The thing, you ask a great question. How can I prove? So you're asking really not the right question. How can I prove that these things don't last a long time? I don't think that's my problem. Because we started this talking about peanut butter and jelly sandwiches on the surface of your backyard. Right? I don't have to prove that that's going to not last a long time. You can watch it yourself and know for yourself. They have to prove that this stuff is old. And they can't do that. That's the problem. I don't have to. Because it's their problem. It's not mine. I'm young Earth. Yeah, I expect soft tissue. Why? Earth is young. Bible says so. He's old Earth. He's got to prove that there's a mechanism that preserves this, and so far they have failed. So all my argument is, why is this here? If it's that old, why is it still here? How can it be here? You haven't offered any good explanations for me, sir. The ball is in their court. It's not my problem. You see that? So don't make it your problem. Okay. Yeah. You see that? Yeah. Make it their problem. You don't have to explain it.
We're going to take Emma's question, and then hybrid kids, you're going to need to quickly pack up, and your parents will be picking you up. Everybody else can stay, and you're going to be next after Emma. You've been waiting so patiently.
Let me just say thank you, guys. God bless you. You're awesome. Come to our lab when we build it and get trained and do this work with us, okay?
Yeah. All right, Emma's question, and then we'll...
How many years have you been studying dinosaur bones?
I have been studying dinosaur bones since 2000. The first one I looked at was a T-Rex femur. It had been sitting in a museum drawer for 100 years, and Joe Taylor sent it to me. He's a creationist in Texas. And I cracked it open, and I found all the soft tissue in it. So it had been sitting in a drawer for 100 years. And that, after my publication, a lot of researchers went into their drawers. And there's one study from Canada, just done last year, where they took 16 specimens out of drawers, and they found soft tissue in 15 out of the 16.
Wonderful. All right, let's thank Dr. Mark. Hybrid kids, you need to pack up your things. And Geo, go the way of the dinosaurs. Bye-bye. See ya. Don't really do that. Okay, and we're going to have one more question. You've been waiting so patiently. And then we're going to have a little time for those of you who are here visiting to look through the exhibits. And then Altoona kids, you're going to have a break. Last question. This is the big one. You ready?
Are you ready?
What's your name?
Vita.
Hi, Vita. What's your question?
How far in the bone would you find the soft tissue?
That is a great question. We dig deep into the bone. One of the reasons we do that is we want to cut away all the bone that may have been influenced by the surrounding, the nematodes that you saw, bacteria, plant roots. A lot of these bones are riddled with plant roots. Why? It's biology trying to get at biology, right? They're trying to get that food. So we often shave away a lot of the outer part of the bone, and then we decalcify. But we tear up bones like crazy. It's what we do. We destroy bones. So don't bring me your precious bones, because I'll dissolve them.
Okay. Thank you so much, Dr. Mark. Great questions. Very attentive audience. Good job today. All right. And you guys can be dismissed. And for those who are going to participate,